What if I told you that right now, at this very moment, an object the size of a mountain range is tearing through our solar system at an unimaginable speed over 210,000 kilometers per hour, and scientists are completely baffled by its behavior? Not NASA, not the European Space Agency, not the brightest minds on Earth can fully explain what it's doing or why. But what happens next is nothing short of extraordinary, and it will completely change how you think about space. If the mystery of 3I, Atlas, excites you, hit that like button now to let the universe know you're watching, because every click helps humanity keep its eyes on the unknown. Right now, something is unfolding in our solar system that challenges everything we thought we understood about comets, interstellar objects, and what might travel between the stars. This object, called 3I, Atlas, is only the third confirmed visitor from beyond our solar system, and what it's doing simply shouldn't be possible. The deeper scientists examine it, the stranger it becomes. But before we dive into the most shocking parts, it's crucial to understand why 3I, Atlas, is unlike anything we've ever encountered. Most space stories have neat explanations. This one doesn't. The closer you look, the more complex it gets. Our story begins on July 1st, 2025. The Atlas Telescope Network, designed to spot objects that might threaten Earth, detected a moving point of light against the backdrop of stars. At first, it seemed routine, just another object to catalog and track. But when the calculations returned, astronomers realized something was wrong. Its trajectory wasn't elliptical, it was hyperbolic. For context, an elliptical orbit means an object is bound to the sun, circling it repeatedly. A hyperbolic orbit means the object is not bound at all. It is passing through, coming from somewhere entirely unknown and destined to leave again. Scientists traced its path backward, checking the Oort cloud, the Kuiper belt, every known source of solar system material. Nothing matched. 3I, Atlas, did not originate in our solar system. It came from between the stars. And while it's only the third interstellar visitor ever confirmed, it is by far the largest and most active we've ever seen. Now, here's why you need to pay attention. 3I, Atlas, measures between 2 and 6 kilometers across roughly the size of a small mountain range, compressed into a single object. Its mass is around 30 billion tons. Traveling at 210,000 kilometers per hour relative to the Sun, it moves fast enough to cross the United States in just 90 seconds. And what it does next would confound even the most seasoned astronomers. The first anomaly appeared in August 2025. The Very Large Telescope in Chile aimed its instruments at 3I, Atlas, when it was still nearly 4 times farther from the Sun than Earth. At that distance, the object should have been frozen solid, a lifeless chunk of ice and rock drifting silently. Instead, the spectroscopes revealed something impossible: glowing nickel vapor surrounding the object like an invisible halo. Nickel boils at nearly 2,913 degrees Celsius, yet the surface temperature of 3I, Atlas, should have been around minus 150 degrees. That's a gap of over 3,000 degrees. No natural heating from a star that far away could explain it. And here's the kicker. There was no iron. Every known comet or asteroid containing nickel also contains iron. But 3I, Atlas, had nickel without a trace of iron. Finding smoke without fire might be a better analogy. Scientists speculated about unknown compounds breaking down under ultraviolet light, releasing nickel, but nobody could identify these compounds. The mystery only deepened when the James Webb Space Telescope observed the object, revealing evidence of a surface transformed over billions of years by galactic cosmic rays, forming a deep irradiated crust that had fundamentally altered its outer layers. This isn't just a frozen traveler. It's a survivor, and beneath that hardened shell lies secrets that have never been touched by human eyes. What lies beneath that irradiated crust is one of the greatest questions in modern astronomy. The James Webb Space Telescope's observations gave us a glimpse into the comet's coma, the cloud of gas surrounding its nucleus, and what it revealed was astonishing. Unlike every comet in our solar system, where water dominates by 80 to 90%, 3I, Atlas had far more carbon dioxide than water. Not slightly more, significantly more. This matters because comets are essentially frozen time capsules, preserving the conditions of the star system where they formed billions of years ago. Carbon dioxide freezes at far colder temperatures than water ice, meaning 3I, Atlas likely formed in an environment far colder than anything we know in our own solar system. Some estimates even suggest it might predate the Sun itself. Imagine that, a traveler older than our solar system, drifting through the galaxy long before Earth had formed, now passing through our cosmic neighborhood for the very first time while we have the technology to witness it. As 3I, Atlas approached its closest point to the Sun in late October 2025, astronomers observed something that left them scrambling for explanations. Its brightness didn't just increase gradually as expected, it exploded. The comet's luminosity surged at twice the previous rate in a matter of days. Radio observations revealed an outflow of water molecules that was 40 times greater than the month prior, an almost incomprehensible surge. Scientists compared it to a fire hose turned on full blast, and yet the reason behind this sudden release was just as fascinating as the numbers themselves. Initially, carbon dioxide escaping from the outer layers acted as a cooling blanket, shielding the water ice beneath. But once this layer ran out, the water ice was suddenly exposed to the sun's radiation for the first time, causing a rapid, almost explosive release of gas. This sequence wasn't random, it was precise. The outer protective layer controlled the timing, and the moment it failed coincided almost perfectly with perihelion, the comet's closest approach to the Sunday. This mechanism, with its distinct phases, had never been observed with such clarity in any other comet. And if that wasn't enough, 3I, Atlas's journey brought it extremely close to Mars. On October 15, 2025, it passed within just 12 miles of the planet. That's not 12,000 meters, it's 12 miles. NASA's high-resolution camera aboard the Mars Reconnaissance Orbiter captured the closest images ever taken of an interstellar object. These images weren't just clear, they were extraordinary. They offered the potential to reveal surface structures, jet formations, and even subtle color variations on a comet from another star system, but researchers remained cautious in their descriptions, hinting at observations that might redefine what we thought we knew about interstellar objects. As 3I, Atlas neared perihelion, space-based telescopes, including SOHO, Stereo A, and the GOES-19 satellite captured a new anomaly. Unlike any other comet, it displayed no visible dust tail, just a faint, elongated glow, primarily composed of gas. Comets, by definition, release dust when ice sublimates, but here was 3I, Atlas, defying that rule entirely. Then, on October 27th, Russian astronomers monitoring the object witnessed something extraordinary. A massive coronal mass ejection from the Sun, a superheated plasma wall traveling millions of kilometers per hour, powerful enough to disrupt satellites and power grids on Earth, hit 3I, Atlas directly. Normally, such an event would fragment a comet or at least disrupt its trajectory. But 3I, Atlas remained unscathed. Its path, speed, and structure were unaffected. A 30 billion-ton object, absorbing the energy equivalent of millions of nuclear bombs, yet continuing its journey as if nothing had happened. At this point, scientists were divided. Could a natural comet behave this way, or was there something more to this visitor? Some argue that 3I, Atlas's unusual behavior, stems from its interstellar origin and extreme age. But others, including Avi Loeb, former chair of Harvard's astronomy department, have urged NASA to release all available data. Every instrument pointed at it holds insights into what is really traveling between the stars and possibly clues that could challenge our understanding of the natural universe itself. When you line up everything we know about 3I, Atlas, the pattern starts to get uncanny. Consider its age estimates. Suggest it could be 7 to 12 billion years old, possibly older than our Sunday. It carries a mass of 30 billion tons and travels at hyperbolic velocity, meaning it is not bound to our solar system, but is passing through from deep interstellar space. Its outer layer, hardened by billions of years of cosmic ray bombardment, shields whatever lies beneath, preserving secrets that might never have been seen by any civilization, if any ever existed around its original star. Its composition is equally perplexing. Nickel appears without iron, carbon dioxide dominates over water, and its explosive activation at perihelion occurred with pinpoint timing. Its close flyby of Mars at a mere 12 miles distance against astronomical odds, calculated at less than 1 in 50,000, adds another layer to this enigma. Most comets would have fragmented or at least altered course under the same conditions, yet 3I, Atlas, remained intact, on a trajectory exactly as predicted, and it had no dust tail, defying what we know about sublimating comets. Every anomaly alone might be explained by natural processes, but together they form a sequence that has left researchers uneasy. Avi Loeb has suggested that if advanced civilizations wanted to send something across the galaxy, they wouldn't build shiny spacecraft with lights and antennas. Instead, they would design it to survive the journey, to blend seamlessly with natural space objects, and to carry their message or material intact. In other words, if an interstellar probe existed, it might look exactly like a natural comet unless we analyze it with extreme precision. While the evidence for a natural origin remains strong, the very fact that qualified scientists are discussing the possibility of artificiality highlights just how unusual this object is. As 3I, Atlas continues to leave the inner solar system, researchers are closely monitoring how its activity evolves. Will the outgassing fade as solar heating decreases? Will the spectrum reveal more about the pristine materials beneath the irradiated crust? Could Jupiter's gravitational influence produce subtle deviations in its path? Every observation has the potential to unlock new understanding, and astronomers are paying close attention. This isn't just a comet. It's a window into the galaxy's history. For billions of years, 3I, Atlas drifted through the darkness, a survivor of conditions we can barely imagine. It may have formed around a star that no longer exists, passing silently through interstellar space while entire civilizations rose and fell elsewhere. And now, in the brief moment of human technological capability, it is passing through our solar system, giving us the first opportunity to witness a true interstellar traveler in real time. The odds of any object from interstellar space crossing paths with our sun are staggeringly low. The distances are vast, the trajectories random, and yet here it is close enough for our telescopes to study, to measure, to learn. Whether this is a remarkable coincidence or something more, 3I, Atlas reminds us that the universe is far more diverse, strange, and unpredictable than our models often allow. As the Vera Rubin Observatory comes online in Chile, capable of surveying the entire visible sky every few nights, the discovery of interstellar objects may become far more common. Instead of encountering 3 objects in 8 years, astronomers may observe dozens annually, each carrying the chemical fingerprints of a distant star system. Each one could be a time capsule, a messenger, or a puzzle, just as 3I Atlas is, offering humanity an unprecedented window into the cosmos. And yet, despite all these discoveries, one question remains: what is 3I Atlas really? Is it a natural comet shaped by billions of years of cosmic evolution, an ancient artifact from a stellar system long gone? Or something entirely beyond our current understanding? The universe doesn't give easy answers, but it does provide clues, and this 30 billion ton traveler is leaving them for us to decipher. As 3I Atlas moved past its closest approach to the Sun, scientists' attention shifted to what happens after perihelion. This phase can be just as revealing as the approach itself, and in the case of 3I Atlas, it promised even more surprises. Early observations showed that as solar heating decreased, its activity didn't simply fade in a predictable way. The gas emissions, previously dominated by carbon dioxide and suddenly releasing massive amounts of water, were evolving in ways that defied conventional models of comet behavior. Each instrument pointed at it returned data that deepened the mystery. Even more astonishing was how 3I Atlas responded to solar activity. Just days before perihelion, it endured a direct impact from one of the most powerful coronal mass ejections of the current solar cycle. This superheated plasma, moving at millions of kilometers per hour, carried the energy of millions of nuclear bombs. Most comets exposed to such a storm would shatter or fragment. Debris would scatter, forming new trails across the sky. But 3I Atlas was different. Its signal weakened temporarily during the impact, yet it maintained perfect structural integrity and followed its predicted trajectory with 0 deviation. This was not approximate, it was exact. A 30 billion ton object absorbing energy that could obliterate satellites and yet emerging completely unscathed. This alone challenges everything we thought we knew about the physical limits of cometary materials. Scientists debated, could a natural comet withstand such an extreme event? Some argued yes, citing its interstellar origin and the resilience gained from billions of years traveling through cosmic radiation. Its irradiated crust, a layer hardened by cosmic rays, might have acted as a shield, protecting its interior from both solar radiation and plasma storms. Yet even with this explanation, the precision of its survival, its trajectory, speed, and structure unchanged remains astonishing. Others, including Avi Loeb, emphasize the importance of examining the data openly. The third confirmed interstellar object ever observed represents humanity's rare chance to study what really moves between the stars. Every measurement, every observation may hold insights into processes and materials entirely unknown to us. 3I Atlas's story also intersects with human-scale perspectives. Think about the odds of any interstellar object passing through our solar system at all. They are staggeringly low, and yet here it is, traveling past the Sun, close enough to our planets and satellites to be studied in detail, revealing behaviors and compositions that challenge centuries of astronomical assumptions. Its flyby of Mars at only 12 miles, the absence of a dust tail, the explosive water release, all anomalies that individually might be explained, but taken together form a pattern that seems almost deliberate. Looking beyond, the implications are profound. The Vera Rubin Observatory in Chile promises to detect dozens of such interstellar visitors every year. Each could carry secrets from other star systems, each a time capsule of cosmic history, far beyond our own sun's neighborhood. But none will be quite like 3I, Atlas, at least not yet. This is the first interstellar object passing through our solar system, while humans have the technology to study it in real time, revealing both the strange diversity of the universe and the limitations of our current understanding. And yet, while the data is rich, the questions remain. What does 3I, Atlas's survival, tell us about material science in extreme interstellar conditions? What lies beneath its hardened surface? Could it be carrying organic molecules, or even complex chemical structures preserved for billions of years? Every answer we uncover only reveals deeper mysteries, inviting us to rethink the assumptions we have made about comets, interstellar space, and the history of the galaxy itself. By this stage, the anomalies of 3I, Atlas were stacking up, creating a puzzle that has left even the most seasoned astronomers scratching their heads. Let's take stock: a 7 to 12 billion year old interstellar object traveling at hyperbolic speed with a hardened outer crust from billions of years of cosmic radiation, carbon dioxide dominating over water, nickel vapor without iron, explosive water released precisely at perihelion, no dust tail, survival of a direct solar plasma storm, and a near impossible one, 2-mile Mars flyby. Each of these anomalies alone might be explained by extreme cosmic circumstances, but together they form a pattern unlike anything ever observed. Avi Loeb, former chair of Harvard's astronomy department, has repeatedly argued that NASA should release all observational data on 3I, Atlas, to the scientific community. He points out that this third confirmed interstellar object offers humanity a unique chance to study material from beyond our solar system, potentially containing chemical or structural signatures that could expand our understanding of physics, chemistry, and cosmic history. Every instrument trained on it, from radio arrays to space telescopes, has collected data that may reveal insights about interstellar travel, survival under extreme conditions, and the evolution of objects across billions of years. Some researchers insist 3I, Atlas, is entirely natural, a comet shaped and transformed by billions of years of interstellar travel, evolving under conditions far outside the range of our solar system comets. After all, our models are based almost entirely on local examples. This object originated elsewhere, under colder, more extreme, and older conditions than anything we've ever seen. It's possible that all of its strange behaviors are the natural result of these circumstances. Yet others are more intrigued by the thought experiment. If an advanced civilization were sending probes across the stars, they wouldn't need them to look like science fiction spacecraft. They'd design them to survive, blend in with natural objects, and carry their materials intact for billions of years. And that's exactly what 3I, Atlas, looks like: a natural-looking object with extreme durability and unusual properties. While the evidence leans heavily toward a natural origin, the very fact that serious scientists are considering the possibility of artificiality is extraordinary. It signals that we are beginning to understand what it would take to identify interstellar technology hidden in plain sight. The conversation around 3I, Atlas, is not just theoretical, it's practical. Every observation teaches us how to distinguish natural from possibly artificial objects in interstellar space. It challenges our assumptions, tests the limits of physics, and forces us to confront the sheer diversity of the galaxy. And as 3I, Atlas, continues to move away from the Sun, astronomers are watching closely to see how its activity declines, whether its spectrum changes, and whether gravitational interactions with planets like Jupiter reveal any unexpected behavior. In essence, 3I, Atlas, is teaching humanity a new language for interpreting the cosmos. It is a teacher disguised as a comet, offering lessons on the origins of stars, the physics of extreme environments, and the challenges of identifying what truly lies beyond our solar system. And the story is far from over, even as 3I Atlas drifts back into the outer solar system. The lessons it offers are profound. This object survived conditions that no comet from our solar system could endure: a direct solar plasma storm, rapid heating, massive outgassing, and close planetary encounters, all without losing structural integrity or deviating from its trajectory. It has given us the rare opportunity to study an ancient interstellar traveler up close, revealing secrets of formation in a distant star system and the resilience required to survive billions of years in deep space. Consider this: 3I Atlas may have formed around a star that no longer exists, traveling across the galaxy long before Earth itself coalesced from cosmic dust. The civilizations that might have existed around its original star, if any, did rose and fell billions of years before humans walked the Earth, and yet, in the brief window of human technological capability, it passed through our solar system, allowing us to observe, analyze, and question what is truly out there. The Vera Rubin Observatory, soon operational, promises to revolutionize this field. Instead of encountering just a few interstellar objects every decade, astronomers may observe dozens each year, each carrying chemical fingerprints of their home systems. These objects will act as time capsules from distant stars, each one a chance to unravel the mysteries of formation, evolution, and survival in the harsh environment of interstellar space. 3I Atlas was the first of our generation, a harbinger of discoveries to come. So what is 3I Atlas really? A natural comet with an extraordinary history? An ancient messenger from a system long gone? Or something completely beyond our current categories? The truth remains elusive, but the questions themselves are invaluable. Every observation challenges our assumptions, every anomaly hints at deeper cosmic processes, and every phase of its journey provides insight into physics, chemistry, and astronomy far beyond Earth. As we watch it recede into the void at 210,000 kilometers per hour, one fact becomes clear: the universe is far stranger and more complex than we often imagine. The 30 billion ton enigma we call 3I Atlas is a reminder that the cosmos has secrets, and some of them are passing through our neighborhood right now, waiting for us to uncover them. If this story has captivated you, don't stop here. The universe is full of mysteries far beyond our imagination, and 3I Atlas is just the beginning. Hit that like button, subscribe, and turn on notifications, because in the next video, we'll explore even more astonishing cosmic phenomena secrets that could redefine what we think we know about the stars, the galaxy, and perhaps even ourselves. Stay curious, because the universe is always watching, and its story is far from finished.